Good afternoon, everybody. Welcome to the IFC4precast part this afternoon. Let me introduce you to our group and give an overview of what happened in this project group the last month. The members of this group are most of all software vendors from CAD systems like Precast Software Engineering, Thomas, and from IDET, and also from Trimble, Tekla is also in this group. And what members are also are from the MES system, manufacturing execution systems for the precast industry, like RRB from our side, and Progress Group and Unitechnik. Also AEC3 is part of this group, and FDU as a stakeholder, let's say, or a customer from our side. Generally, the purpose of this group is more oriented in the automation of precast industry. So we are focused on software and robots for MES system especially. They are therefore for putting the CAD information to the machinery and to the logistic in the factory. And this is why these stakeholders very interesting in having a standardized interface in this precast industry. In this group we had the decision to have 3 speakers out of this group for marketing, for official things, and for driving this group forward. First of all, Benno Strack is from FDU company. He's, let's say, the driver, and he launched this initiative to build this group because the FDU as itself has about 25 factories, precast factories in Germany, and is one of the biggest precaster in Germany as itself, maybe worldwide as precast industry. And he said he needs a standardized interface between CAD systems and MES system, especially for those systems, and maybe also in the future to the machinery. Because at the moment there are so many different interfaces and really weak interfaces for these issues. Myself, Stefan Maier, I'm from RRB SAA. I'm about roughly 13 years in this industry, and I began as a software developer and now making head of the MES systems and the PPS system. And the third speaker is Werner Marisch, the managing partner from Precast Software Engineering. It's part of the Nemcheck group also. And together with me today is Thomas. Maybe you want to say some words from your side?
Yes, I'm a BIM consultant at Precast Software Engineering, because we face that BIM is a very interesting topic also for the precast industry, and so my topic is to make consulting for precast factories to bring BIM and all these topics into the precast branch, and therefore it's a topic for me also to be part of this group, to be part of this IFC4precast group, to bring this technology into the market.
Okay, let's see, what was the motivation to build this group and have this initiative? Everywhere you go today, you hear you need BIM and you need this integration of all this model, and what we have in the precast industry is not state of the art from the technology part here. And we want to go further and have this integrated software systems and this BIM idea also in this precast industry. The current interfaces are limited in several parts. There is no three-dimensional information in the description of the interfaces. You don't have the unique IDs, and a lot of things for description of parts is not good enough today. For few projects we had special descriptions where we use fields in the interfaces which are not made for the use of this kind of transaction between the systems, and this is really weak and not a let's say a good and state-of-the-art job to speak with each other in software terms. Yeah, what we also saw is we had a workshop together with Thomas Liebig that it is technically the right time with IFC4 to use this and to go in this direction. We have the possible segmentation in IFC4. That means you don't need to export a full house. You can export also panels, panel by panel, and this is really necessary in the precast industry because normally you produce panel by panel in a factory. You have the suitable entities, most of them are ready. You will see it later. You have also very good tools for documentation and tools to view the IFC exports. Yeah, and it is in principle widely supported by the different viewers in this part. And what was also a thing we thought about is that buildingSMART could support us to bring this topic of an international standard, and that everybody worldwide will use in future this kind of interface and work together. This was also the reason why these software vendors here in this group, let's say, are from our point of view the market leaders in the world, and we think that if we bring some kind of IFC4precast standard out, then this should be used also worldwide. This is the goal for sure. Strong project group, I mentioned that already. Okay. As I said, it is the goal is to create a universal basis for this process optimization and information distribution all over to the software systems, and bring this BIM idea stronger to the market. What we also want to, that the CAD systems and ERP system or specialized PPS and production planning systems can link each other better and have this information better solved. And we want to use the let's say industrialized standard, not the specific precast interfaces for these things. And clear traceability, whole through the model, back to the site, back to the project, and also to the whole house, that you know each part, where is it located, and that you have the traceability inside your project. Okay. What can also be in the future used is the BCF format for getting some information back. This should be also part of this. For example, if you want to know the status of an element that it is produced, you want to color your house with this status, then you want this information back from the production information system to the ERP system, for example, or the CAD model. What we also want to have is a small project group, and to have an agile software development inside this, and to move forward very fast, and not to have too big discussions and it's too slow then afterwards. What we also wanted is a low project management cost. It was also focused. We handled like this, that every vendor hosts a session or a meeting in person once a year or something, and next time another vendor hosting this session. And what we also have is a professional consultant from AAC3, the company from Thomas Liebig. Sergej Mujic is helping us with details, and especially with the IFC knowledge in this group, because all the software vendors are specialized, not so familiar with IFC at the moment, and they help out here. So I want to show here what's the normal picture in a precast plant or big precast factory today. When you have the architecture model, MEP model, and structural engineering model, you put this in the precast CAD system, whatever precast CAD system you use, and they make the detailing. And after the detailing, this information goes normally, if you have to the precast ERP system, where you make the rough planning for your plant. You say, I need those trucks for delivery, I need those material, and so on. You make the rough planning, and after that, you give this information and the panel information, especially to the precast MES systems, the manufacturing execution system. A master computer is there behind, and it makes the machine data specialized for the machines, and it makes the logistic within your factory. Yeah? And the exchange between these systems, the basics are the Unicam interface. That's really an, let's say, precast specific interface, as already also the PXML or CPI XML is also used for three-dimensional information. And for costing information, there are some other interfaces available. But as you can see, it is not really a standard. Everybody is using different interfaces and really weak interfaces. These are traditional ones, 30 years old, and were not designed for 3D information between those systems. So, thinking of FDU in Germany, they have different factories, and they also use different precast CAD systems. Yeah? They also use different precast MES system, and each factory is individual from the machineries also. So what we have here is that in the future we want to use the IFC precast information going from the CAD system to the MES system, and maybe also in the future to the machines. So what IFC is today really not is an interface for automated production. And that is what is needed in this interface, in the property sets and all those things. What happened in our group the last month? We had a roundtable in June 2016, and the first workshop with feasibility study in August 2016, together with Thomas Liebig, and there we found out that it's really IFC is suitable and is good enough to face also this precast industry, and we want to move forward with IFC. Yeah, after that, several workshops happened, and we had a presentation. And in June this summer, we have launched, let's say, the version 0.8, and now the software vendors from the CAD part and from the MES part are started to implement this interface definition. And the goal is, Mr. Strack said he wants to produce the first element in the mid of November, and we will produce on 11th of November the first precast slab with this interface definition, and have let's say a showcase which we will present at the end of November at our engineering days. That's a precast industry-wide event for software vendors and customers and all this stuff. Okay, maybe I'll switch to Thomas now.
Yes, we started first to define the exchange requirements. We started very simple, taking an Excel sheet, writing down the requirements for the different parts of a precast element. You see here a detailed description. I know you cannot read it, but we did many descriptions and tried to describe here the different parts. Here, for an example, an isolation element, or here something for the production. And this was the start to figure out what are the topics which we have to solve in this new interface. And then, after many discussions, we agreed to a general object model. And this object model I will like to explain a little bit. So first we start with the project. Project is a precast project. This is not the full construction, because a construction can be partly out of precast elements and partly be of on-site concrete. So our project view is the precast part of a construction, but actually this project is in a building, and the precast elements are in a building story, and here we have the elements. In some cases it's not necessary to have all these standardized IFC objects, but we can work with them, and we know also that some elements or objects are mandatory. So then, if you have a precast element, this precast element can consist of different layers. Okay, so we have here another important object class which is the part of an element. This can be, I will show you later some examples, for example, the isolation part or the isolation layer or the concrete layer or anything else. And then we have created, or we use the complex object as the basic object to create complex reinforcement or easy reinforcement. So you see an element can have only simple reinforcement bars, or an element, and precast element, can have complex object, for example a cage, and this cage consists of reinforcement bars. And the last element in this object model are the fixtures, like electronic devices, like pipes, all these things which are inside the precast elements are the fixtures. And these fixtures can also be complex object, because a fixture can consist of other fixtures. You see here also some loops here. A complex object can consist of other complex objects. You see here on the other side, we have here our project. This wall consists of reinforcement, some single reinforcement bars. Then here we have cages, meshes, some complex fixtures here, or some fixtures which are only one single fixture which is put in the precast element during the production. So, which IFC classes do we use? This is only IFC project, IFC site, IFC building, IFC building story. These are the standard classes. Then here for the element, we use IFC element assembly. We do not make a difference between wall, slabs, and other precast elements, because from the production side, it's a precast element. And all these precast elements will be produced on a flat thing, like a table, like a pallet, which is moving around in the precast plant, or on other stations in the precast element. So it's not necessary to define here that it's a wall or it's a slab or something like that. But later on, we will use predefined types to identify or to give more information to the precast elements. Yes, and then we have here only three other object classes of the IFC model: the IFC discrete accessory, building element part, and the reinforcement bar. And this was the concept, and then we tried to model different precast parts only with these IFC classes. So this is very simple. Here we have a project. This project is on a site. On this site we have some buildings, maybe one or two buildings, and each building has a building story where the elements, the precast elements, are located. So this is very simple, and the proof was very fast that this system is working. But in the next step, we looked in detail on the different kinds of precast elements. For example, this is a precast slab. We have here one element, and we have two parts. The first one is the precast part, which is made in the factory, and the second one is the site mixed concrete, because when you bring this slab on the construction site, you put on site concrete here to fill in this this part of this slab, and then the slab is finished. And in fact, the engineer working with the CAD system has to plan this layer here, the thickness of this layer, and also the thickness of this layer, to define that this whole slab is, for example, 6 or 10 centimeters. Next example is a solid wall, which consists only of one level, so very easy. We define the geometry of this element only by describing the geometry. So we do not say that this is a door or this is a window. We are describing the whole geometry of this element, because this is the important information for the production to make the production with the machines automatically running. This is not a typical example, because we do not put the whole door or the window with the glass during the precast production into a wall. Normally we do only the hole, and sometimes we put into the wall the frame of the door or the window, but nobody will do the window with the glass during the production in a precast wall. But we have an element, we have two fixtures, and also the layer, which is only one, because we have only one precast layer for this wall. It's a little bit different if you look on a so-called double wall. A double wall consists of two small parts of precast elements which are fixed together during the production process. You bring this wall on the construction site, and then you fill in concrete in between here to make it to a full concrete wall. The reason for that is that the weight of this wall is not so high. Then you have a massive solid wall, and you bring here in the concrete. But it's the same. We have in this case three layers. The first one is the first part of this double wall. Then we have the side mixed concrete layer. And then we have another prefabricated layer in this wall, and also some fixtures for doors and windows. Yes, but also we have some articles or products which have an insulation in between the two precast slabs. It's not different if we fill in the concrete on side like a double wall, or we have here an insulated wall. We just have to change this layer here from a concrete layer to an insulated layer. It's only a different material, but the concept also works for such walls like that. And if you have a fourth layer, for example, where you put something on the facade, like tiles, thank you, then you create a fourth layer, and then you define the material and the thickness of this layer. All these things can be done in the precast factory. Also looking a little bit in the reinforcement, a very simple reinforcement is this. So we are just writing reinforcement bars created by the CAD system of the precast CAD system. This is a very simple, but if we have cages or meshes like that, which are part of the reinforcement, so we have a reinforcement group. We discussed this also after your presentation. We model this as a complex object, and this complex object can have reinforcement bars, or maybe if it's a very complex cage, we have a complex object, a reinforcement group, which consists of other reinforcement groups, and these reinforcement groups consists of reinforcement bars. So this is a hierarchy, and we can do every details which are necessary to do this reinforcement. A special thing in the precast industry is the so-called lattice girder. This is necessary for these slabs I have shown before. This lattice girder consists of 5 different reinforcement bars, but in fact, from our point of view, it's also a complex object consisting of 1, 2, 3, 4, 5 different reinforcement bars, maybe modeled a little bit different from the geometry, because we have here only the straight bars 1, 2, 3, and here the diagonal bars, but this is only a question how to create the geometry, and this is not a really problem. and we summarize them, we group them in this complex object to make this lattice girder working. In some cases we have also mixed element parts here. This is, for example, a bar with spacer. When you move a bar during an automatic production on the production place, you need a so-called spacer that the bar is not laying directly on the floor or directly on the production level. So you need a spacer that there is a place for the concrete to flow under this bar. For our object model, it's not a problem. So we have a complex object which consists of reinforcement bars and different fixtures. Yes, last example. Here a very complex but very common fixture. We are just discussing how we want to describe this, because the question is how many details do we want to describe in the IFC. It's just a fixture with only the geometry, the surrounding geometry, or is it necessary to really describe here the isolation part and each part, each reinforcement part here stacking in this isolation? This is just an open question, and we are trying to find a solution for that, how we can describe it. Okay, this is not only some slides. As Stefan mentioned, we also implemented this, and I will show you a short video. This is the export of our precast CAD system, and we are visualizing this in the FZK viewer. So this is a simple house with different precast elements. We have here the levels, the first level and the basement. You can click here. We see here on this right side the different properties of these elements. Now we have here one element, one slab element. We can also visualize the reinforcement on this slab level, on this slab. We can also see only the concrete or only the reinforcement bar, and if we visualize here, we see the reinforcement of this slab described in the IFC4precast, and also the different fixtures with the different pipes connecting these fixtures here. And here we have the lattice girders as described before. Only one. And here on this right side we see the type of the IFC class and also all attributes which are necessary. Now a solid wall with the reinforcement maybe a little bit complex, so here to show you that we also can use these complex objects here, very detailed, modeled. And the last example is a double wall to show you that we have the different layers. This is the full wall, and now we have the different layer. This is the first layer, very small. This is the on-site concrete layer, and this is the second layer here, and also the reinforcement, which is now something like that, because, okay. So what we did is we had many workshops to discuss the solutions, but parallel we started to implement to find out if the discussions and the results of the discussion fit to the data we have available in our precast systems. And so this is the result for many standard precast elements, and we found out that this object model and this structure will work.
Yeah, what we also use, sorry, as I already mentioned, is the IFC doc tool. We are quite not finished with our solution, with the interface description, but as now we already build in the appropriate entities here and put that together, have the classification concepts and properties already inside the IFC doc. What we also started is here the MBD documentation, and as you know, as you see, the IFC element assembly is a basic instrument for the other specification. It is also the base for a complex object, for the complex reinforcement, and for the building element here inside this part. And what is also used as a project platform, this is a software tool from IFC3. It's used to put in the definition from IFC doc in this tool, and afterwards you can export this MVD ready for using this data in your software systems. And what you can also do is you have the old interfaces described here in this tool, and you can look what kind of properties or attributes are not part of the IFC4precast, and to know what is not part of the IFC4precast now. Yeah, the next step, as I also mentioned, is we have a big software environment at the FDU group. It's a virtual environment where we can test all the implementations. We have 3 CAD systems there on virtual machines from each vendor, and we have 3 MES systems also from each vendor. And it's possible to put data from each CAD system to the different MES system and test it before we go to the production. I can say for our system, normally you can test it, let's say 95% in advance to the production. You can say that it will work when you go to the production, to the live machineries, because you can control what's the output of the MES system to the machine, and can say, okay, that looks good, and it's really a virtual environment where you can test the whole system 95% in advance. Yeah, and FDU support this environment and built that up, and we already installed our systems there and doing the testing.
And hopefully mid of November we will produce, as you mentioned, the first element.
Yeah.
In fact, it's a very simple element, but we want to check if that what we are creating in the different precast CAD systems, when we pass that to the MES system, they can read in that, they can visualize this, and they can generate machine data for the different machines, and then we are sending that data directly to the machines, and then we produce this. And in the next step, we will use more difficult examples like walls, like double walls, more fixtures, to improve this concept and to see if this whole workflow from the CAD system to the machines is running.
With 0.8, it's a rough estimation of the definition. It's not the definition of how far is the software and the software vendors with the implementation, because what happens now is that it's mind changing a little bit, and also from the process side changing the software system and how the process is going to work, because more information in the past was on the CAD system. They put in more production relevant information already for shuttering systems and so on, and now it is more general description. You have the full model going to the MES system, and the MES system should decide what should happen in the production. So you need more intelligence on the MES side in the future, and this is going to be more difficult here, and also for the implementation it's going to be a hard work and a long way to finish this journey. But what is also clear statement from our side is that there is no let's say end date for this group. We want to go on also in the future. If we say we have finished this part between the CAD and the MES system, we want to go further and bring it to the ERP system, to bring more financial information and material information to the interface, and can also exchange between ERP system, MES and CAD systems. And also maybe if we have new parts or new kind of production information element or parts in the future, we want to sit together and discuss this and bring it to the interface and have a, let's say, a new version, or in IFC5 maybe other entities or something else. So we want to go on in this group, within this group, and what we also started now is to bring more experts from external in, for example from mounting part or fixture vendors in this group, and also get more customers on board. For example, our company Bögel will join the group in near future, and maybe also Unter from Austria. Okay, so this was our overview for today. If you want to have more information, you can go on this websites, or you can contact us directly. This presentation is already on the share file, so if you have any questions, please feel free to ask.
Thank you.
Thank you very much.